When you graph a rectangular coordinate, do you generally move in the horizontal direction first or the vertical direction first? Anybody ever get kind of risky and they decide to move the vertical direction first? No? Okay. Nobody kind of flies that way. All right. Every once in a while, I'll do y first. I'll tell you what, with polar coordinates, you really always want to do theta first. And here's how it works out. If we label this as 0 radians, pi over 2 radians, pi, 3 pi over 2, and 2 pi. You guys know how this goes. We've got pi over 6, pi over 4, pi over 3, so on and so forth. And this is just a general grid that we have for a polar coordinate. So I would like to plot 3 pi over 4, and then I would like to rename it 4 different ways. As I plot it, I first turn pi over 4. I need a volunteer. Braden, you tell me when I've reached pi over 4. What? Right there. So I turn pi over 4, and then I move in that direction 3 units from the center. 1, 2, 3. Not loud enough. Need assertiveness. So that is the coordinate 3 pi over 4. Now what I'd like to do is I'd like to rename it. 3 pi over 4 would be the same as 3 negative 7 pi over 4. Would you agree that 3 negative 7 pi over 4 would put me in the very same location? Why is that? Yeah, if I move the other direction 7 pi over 4 units, so that's negative 7 pi over 4, you can see you then move 3 units in that direction. Good question. I just want you to understand that if you have 3 negative 7 pi over 4, you would be in the exact same position. That whereas 2, 3, there's only one way to arrive at 2, 3, and that's to do 2, 3. Whereas polar coordinates, you can have a number of different ways to write them, and you end up in the exact same position. Okay? So let's try another one. I'm going to do 3, and then I'm going to do more than once around. I'll be 9 pi over 4. How did I get 9 pi over 4? I took pi over 4, and I added 2 pi, or 8 pi over 4. Very good. Now we're going to try one that most people find a little bit confusing, and we're going to do a negative radius. We say that polar coordinates can have negative radius values. Even though that may seem counterintuitive, that's something that we define it as. For example, if I had negative 3 pi over 4, here's how we plot negative 3 pi over 4. You move pi over 4, which is that amount, right? And then instead of moving 3 units in that direction, you move 3 units in the opposite direction. Opposite direction. So if I were to plot negative 3 pi over 4, it would be located right here. See how that's different? So what I'm going to do is I'm going to try to rename this so it has a negative radius. Well, if it has a negative radius, then what I want to do is I want to end up over here, don't I? And then the negative 3 would bring me to this spot. So how far would I turn to get to this spot? Okay, so we've said 2 of them. First of all, you could move 5 pi over 4. So if you have negative 3, 5 pi over 4, that would bring you to this location, and then you move 3 units in the opposite direction. The other one that was stated was negative 3 and negative 3 pi over 4. So you can see that you rotate in the opposite direction, 3 pi over 4 units, and then move negative 3. So all of these are what we call coterminal angles. Okay, I'm sorry, not all of them are coterminal angles, but maybe you could call them coterminal points in that they end up at the same position. Okay. So how about you try? Take this first one, second one, third, and fourth one, and plot them. And after you plot them, try to rename them so they have a negative radius. Instead of negative, we'll say opposite value for radius. So the first one, make it a -1, -3, then do a +3, +4. So plot them, and then see if you can rename them. And when you get one correct, or you believe you have the correct answer, come up to the board and plot it and show me what you got, and then we will we'll talk about what you did correctly or possibly what you did incorrectly. Okay, so here's some options. Were you able to plot it correctly? Okay, so you're able to plot it correctly. Okay, so here's the deal, okay? For the first one, it says that I want to rename this so it has a negative radius or opposite radius, okay? Well, look, 3 pi over 4 brings me to right there. So what I want to do is I want to turn and be at the opposite position. So I want to turn and be, instead of at this spot, I want to be at that spot. So then instead of going 1 unit in that direction, I go 1 unit in the opposite direction. So you want to be 180 degrees away from the other one. So this one right here, you can see that this is a negative pi over 6 and 3. Well, I want to end up over here on the other side. So instead of going 3 units in that direction, I go -3 units. And so this spot would be 5 pi over 6 or -7 pi over 6. Any other questions? Great question from Ella. Anybody else? Going once. Going twice. 3 times sold. Please flip it over. Let's convert from polar or r theta to rectangular, which is xy. How do we do that? Oh, if I only knew. And then we'll convert from rectangular to polar. Well, if I pick a spot that I have r theta, this is my r value and this is theta, you can see that xy would be this x value and this y value. So that kind of makes a triangle, doesn't it? If you see x, it's the adjacent side of the triangle, which reminds you of your good friend cosine. And so we have the cosine of theta is equal to what? X over r. So if you were to solve for x, you would have r times the cosine of theta is equal to x. Does that look familiar? Yes, you've seen this before. This is from your trigonometric form and from your vector work. Okay, if you see y, you think of sine of theta is equal to y over r. So therefore, r sine of theta is equal to y. Any questions how we came up with that? If you want to go from rectangular to polar, well, let's think about it. What would you do with x and y to come up with r? X squared plus y squared is equal to r squared. So r is equal to square root of x squared plus y squared. Does that look familiar? Yes. What would you do to find theta? Tangent of theta is equal to, or y divided by x. You are super smart people. Way to go. Let's try now to actually convert these from polar form to rectangular form. You can see how simple this truly is, okay? So this is r and theta, and I want to move it to xy. So I have to come up with an x value. I have to come up with a y value. How do I come up with the x value? What do I do? 4 times the cosine of 2 pi over 3 and 4 times the sine of 2 pi over 3. Super duper. What is the angle of 2 pi over 3 in degrees? 120. Well, that's a 60-degree reference angle. What is the terminal point at 120 degrees with a 60-degree reference angle? Negative 1/2 and root of 3 over 2. So I have 4 times the cosine of 2 pi over 3 is 4 times negative 1/2, which is negative 2. And I have 4 times the sine of 2 pi over 3 is 4 times root of 3 over 2, which is 2 roots of 3. So therefore, you get negative 2, 2 roots of 3, and that is the rectangular coordinate that matches with the polar coordinate. Look at the sun's almost kind of coming out. Isn't that nice? Oh, wow. Okay. All right, doom and gloom. Thank you. Okay. Try the next one on your own. Go. Okay, I went through it. I came up with root of 2 and root of 2. Is that what you got? Can I connect this together for you real quick so you see it in its whole? In its entirety? So here we have it. Our coordinate was, what do we have? Negative 2 and 5 pi over 4. Is that what we had? So if I were to plot this, 5 pi over 4 brings me to right here, right? And negative 2, I move 2 units in the opposite direction, so I'd end up at the blue spot. Is that correct? Well, we're saying that that is the same rectangular coordinate as root of 2, root of 2. So this is a 45-degree angle with a radius of 2. Does it make sense that this length would be the root of 2 and that this length would be the root of 2? Yeah, sure does. So you can see that when you plot these as rectangular form as polar form, you end up in the exact same position. Okay, let's do the other thing, which is to convert them from rectangular form to polar form. So this is xy, and we want to turn it into r theta. Well, r is equal to the square root of x squared plus y squared. What's x squared? 9. Y squared? And so I get root of 18, which is 3 roots of 2. Now I have to find theta. Tangent of theta is equal to negative 3 over 3, or negative 1. So where's tangent negative? Second and fourth quadrants. Am I in the second quadrant or the fourth quadrant? Why am I in the fourth quadrant? Because x is positive and y is negative. Inverse 1 for tangent, and you get 45 degrees. So therefore, what angle is this? 315, which is 7 pi over 4. So theta is 7 pi over 4. Yeah, very good. So Terry's absolutely correct. You could write it as negative pi over 4 as well if you'd like to. That'll be fine. This is your final exam. So this information will be tested on your final exam. This is definitely a challenging final exam. Okay, go ahead and do this one. Find the polar coordinates. Go. I came up with 10, 5 pi over 6. Is that where you're at? Okay, so when I inverse, first of all, negative, so I'm in the second or fourth quadrant. Second quadrant due to the location of the point. I inverse 1 over the root of 3 on my calculator, and I come up with 30 degrees. 30 degrees is going to make this a 150-degree angle, which is 5 pi over 6. Does that clarify anybody else's question? Okay, see a couple people nodding. Then let's do the last piece, which is we want to convert from to polar form. So that means that we do not want x and y's, we want r's and thetas. We're actually going to show this on our calculator in a little bit. First, let's get an idea of what each graph looks like on its own. I have x is equal to 2y. If you were to graph this, if I divide by 2, I get 1/2 x is equal to y. What shape does that make? It is a line. And it is a line with a slope of 1/2, and it passes through the y-axis at 0. So you can see that this graph is going to look like this. So whatever we come up with for a polar form should be kind of match what we have there. Let's see if that can happen. Okay? I'm going to take x, and I know that x is equal to r cosine of theta. And I'll put the 1/2 in front because I have a 1/2 right there. Equals, instead of y, what do I write? R sine of theta. Wow. What does each side have? An r. Divide by the r. The r's go away. I have 1/2 cosine of theta is equal to sine of theta. So it looks like the r's are gone. So, sometimes equations have only x or only y. In this case, for this polar equation, it's only going to have theta. So let's find out what theta is. How would I find theta in this situation? Divide by cosine of theta and get tangent of theta. 1/2 is equal to tangent of theta. Sweet. Can you find theta? How do I find theta, Terry? You can just punch it into your calculator. Go Gadget Virtual TI Calculator. Go Gadget zip file. This application may depend on other compressed file folders. Let's extract all. Extract. Uh-oh. Ready, set, go. There it is. Sweet. Awesome. Stop laughing, Elena. I expect it from some of them, not from you. Okay, here we go. So let's check it out. I've got tangent is equal to 1/2. So I'm in mode, I'm in degrees. I'll go inverse 0.5, and I get 26. So theta is equal to 26.57 degrees. I would ask you to list it in radians. If we just simply go down to radians and we do the same action, that entry, and we get an answer, we get 0.46 radians. I want you to look at my line that was drawn and see if this makes sense. Came up with a theta value of 26 degrees. As you look at that line, does it look like it could have a slope of about 26 degrees? Yeah, it sure does. And so the polar form of that is theta equals 26 degrees, or 0.46 radians. Think about the next one. X squared plus y squared is equal to 25. What shape does that make? We don't have an R value. We just have theta. So this is my final answer right here. Either one of these would work. Okay. Actually, I would like to have it in radian form, but I probably give you credit for both. This is not a straight line. This is a circle with a radius of 5. So I know that what I should get is that kind of a shape. Okay. That's what we should get. So let's see if we can come up with that. What do we put in for X? R cosine of theta, quantity squared, plus R sine of theta, quantity squared is equal to 25. Oh, boy. See if we can simplify that. I get R squared. Yep, we're going to square it. Good job. You guys are on the ball today. You guys must have gotten some sleep this weekend. What can I do? What can I do? What can I do? What if you did know? No, don't take the square root of everything. There's a plus sign there, dog. Take out an r squared. Thank you. The president speaks forth. That equals 1. Every class has gotten it. I'm so proud of you guys. This is 1 right there. So we got r squared is 25, and we come up with r equals. Are you surprised that we came up with r is equal to 5? No, that's kind of what we thought, right? Yeah, isn't that cool? So take out your calculator. Take it out, take it out, take it out. Press mode. And you guys have worked in function mode your entire lives so far. But I'm going to go down to function, and I'm going to turn it to polar form. What? And now when I press y equals, I get these r values. Now, up until this point, have you ever been able to graph a circle on your calculator? No. Why? Because a circle is not a function. I punch in r equals 5, zoom 6, drop the mic. Now, some people say it's an ellipse. That's because your window is out of whack. If you zoom as a square, number 5, now it's a square window, and we get a perfect circle. Yes, so r is equal to 5, but you need to show all the work. You need to show all the work. Okay, YouTube, we just talked about some really fun graphs that you can make, so that's it. So we move on to the last piece, okay, which is x equals -2. Let's bring this all together so we can understand. We have x equals -2. What shape does that make? What kind of a line? A vertical line. True or false? You've been able to graph a vertical line on your calculator before. False, because a vertical line is not a function. So r cosine of theta is equal to -2. On the first example, we had r completely disappear. On the second example, we had theta completely disappear. Do either of them disappear here? So as you divide by cosine of theta, you can see that r is equal to -2 secant of theta. So I go in there, I do -2 divided by cosine of theta, or secant, or times secant. And as I look at this graph, watch what happens here. There you have it. And so you get a vertical line. Now on your window, you notice here, it starts at a theta value of 0 and it goes to 6 pi. Watch what happens if I do this. I'm just going to go pi to a max of that. Now I'm going to graph it. Oh, it did the same thing. What if I do this? Now it started at the top, went to the bottom, didn't it? Anyway, there's different ways to change around what kind of graph you actually get. But anyway, that's the overall idea. There you go. You have an assignment. There you have it. Please make sure that you follow your notes. I've tried to pick problems that match pretty much with what your notes look like. Good luck. I'm sure you'll do great. Have fun.